This one has a, whatchamacallit? Oh, I have a little bit more there than I thought. So for the convergence test that we have discussed so far, the terms of the series seem to be pretty simple, and the series must have a special look, with the exception of like geometric. Hopefully you did the lesson ahead of this, because we learned about p-series this morning, okay? So any slight deviation from that look or characteristic can make the convergent test not applicable. So for instance, if we have something that, so this one, 1 to the 2, 1 over 2 to the n, that would be something geometric, because I could rewrite it like that, right? This I cannot, because that n just threw the whole thing off. It's very close to geometric, but it's not quite a geometric. 1 over n cubed, that's definitely a p-series. But if I add 1 to that cubed, it's not a p-series, okay? And that's totally different than saying like n plus 1 cubed. That one would be a p-series, okay? All right, if I have something like this, we could probably easily integrate it, but once I throw the cubed on the top, it no longer becomes easy to integrate. So they're talking about maybe applying the integral test. I don't know that any of the ones we're going to have are going to apply integral test today. So we're going to mostly stick to p-series and geometric. That's what we'd like to do, okay? So our goal now becomes to investigate a way to compare series with complicated terms with simpler ones whose convergence and divergence is known, okay? So if I feel like I've got missing things here, I feel like not everything popped in here. Did I have something? Yeah, I've got missing something. All right. There should have been more in that box. So we're going to add the more into the box. If B of n converges, then A sub n converges. So B is going to be your bigger series. Notice it's a jumbo jet, okay? Whereas A is going to be your smaller series. So if your bigger one converges, your smaller one must converge, okay? And that's what it's talking about here, that A is the smaller and B is the bigger. Okay, so number 2, which totally got cut off, and I'm sorry about that. I don't know where to write. I'm going to kind of squeeze it in right here. Okay, so 2 should have said, if the sum as n equals 1 to infinity of A sub n diverges, okay, then the sum as n equals 1 to infinity of B sub n also diverges. That says diverges. Diverges. Okay, you only need to write diverges once. So that one is focusing on if the smaller diverges, then the bigger will diverge. What does not happen, okay, if the bigger diverges, the smaller does not diverge. If the smaller converges, the bigger does not converge. Okay, so here's the acronym for this one. It's bigger converges, smaller diverges. We call it BCSD a lot of the time instead of comparison test. Okay, but that's what that means. Bigger converges, smaller converges. Bigger diverges, smaller diverges. All right, so we're going to look at this, and these ones are kind of frustrating because you have to start getting good at looking for the series that's there. Okay, so I have to find a comparison series. I typically will try to knock something off, because remember, when you're going to infinity, things like this can get knocked off, right? Because it's big, because infinity makes things big. I'm looking for something simpler. So my simpler thing looks like it's right there. So I'm going to compare to that. Okay, so I'm going to compare to the sum as n equals 1 to infinity of 1 over 3 to the n, which I could rewrite as 1 to infinity of 1/3 to the n power. Okay, what kind of series is it? What kind of series is it? Is that a geometric series? Is it a p-series? Would we use nth term? Would we use integral test? Tell me in the chat what you think it is. Big hint, it's probably going to be one of the 2 easy ones. All right, it is in fact geometric, right? Because I've got something to the n power instead of n in the denominator to the power. Okay, so that's a geometric. That's right. What is the R value equal to there? Sometimes I'll just write down which one I'm using. What's my R value equal to? I just want to make sure everybody's with me. All right. It is, in fact, 1/3, which is between 0 and 1. Okay. So when it's between 0 and 1, we know that it converges. So we know that this part, the geometric part, converges. Now I have to make an understanding of whether I have the bigger series or the smaller series. Because we're looking, and we want to look at BCSD, right? Because I just converged, we're going to hope we have the bigger series. Okay, if not, it's an inconclusive test. All right. So I start my explanation by saying since, and I write my original, and I write my new one. Okay, notice I left a gap in between because I'm going to put an inequality sign in there to determine which one's bigger. Okay, we're going to hope our alligator eats the 1/3 to the end. I am going to put in a term. Sometimes I have to put in multiple terms to make sure that this works. Okay, so I am going to put in a term. Andy, is it your lunchtime? Go fix yourself a sandwich right now. Okay, bonus points if you can fix the boys' sandwiches. Okay. All right, so I am going to put in a 1. So when I put a 1 in, I would get 3, and then plus 2 is 5. I'm going to do a 2 too. So I'm going to go 2 terms. I'm just listing them right underneath because this is kind of scratch work. I'm putting in a 2, that would be 9 plus 2 is 11. Okay. I'm going to put the 1 into this one now. So I got 1/3. I'm going to put a 2 and I get 1/9. Do you see how these terms are consistently bigger than the terms on the left? Okay. So correct, Nate, you are correct. It's always going to be smaller because the plus 2 on the bottom is going to make the denominator bigger, which is going to ultimately make the whole thing smaller, right? I like to test it with the terms to make it make sense in my brain, but Nate, you're absolutely correct, and you can use that as an explanation, okay? So we know that that's true. So that means since the comparison series is bigger, we know that the original converges. So therefore, my original series, 1/2 plus 3 to the n, also converges. Andy, go make the sandwich or you run out of time. I'll give you a couple of seconds there. All right, here we go. Let's look at the next one. Okay, 1 over the square root of, I don't know if I have to, yes I did. 1 over 2 plus the square root of n. This one's going to be weird. Okay, so we have the comparison series. I'm going to start just by looking at this. Okay, for lack of anything better, I'm going to start with that and see what happens. I might not be guessing right. Okay, I might not be guessing right on purpose right now. Okay. All right, so I'm going to just say, I'm going to write that I'm going to compare to the sum as n equals 1 to infinity of 1 over, I'm going to say it's n to the 1/2 power because that's the same as the square root of n. All right, so what type of series is my comparison series? Is it a geometric? Is it a p series? Is it integral? Is it nth term? What do we got there? It's not telescoping, right? So what do we have? Let's see if we've got some more possibilities here. So n to a power, okay, versus a fraction or a ratio to a power. That's right. We've got a p series going on here. Okay, so this is a p series. What's p equal to? Can everybody tell me what p is equal to? Oh, there we go. Good, 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 good. It is equal to 1/2. Okay, that whatever the exponent is what the p is equal to. On a p series, and this is where you have to keep going back and looking at the chart. okay, or your series. So what we're going to do is I'm going to put out, I'll probably try to define my log thing of it today. I'm going to show you what the orange sheet should look like. So you've got them all on one sheet, okay, and you can write them out on the one sheet, okay. So P is between 0 and 1, which means, I think it's strictly less than 1, which means that it diverges according to the P-series rules. So therefore, it diverges. So in our BCSD world, we want it to be, we want the comparison series to be smaller than the original. Okay, so let's see what happens. We've got 1 over 2 plus square root of n, and I've got 1 over the square root of n. I don't have to pick in order. I can pick whatever numbers I want. So I'm going to pick some numbers. I'm going to put a 1 in first. Okay, so the square root of 1 is 1. Plus 2 is 3, so that's 1/3. I'm going to go another, okay? I'm going to choose n equal to 4. So because that's a nice, pretty square number, right? So the square root of 4 is 2, plus 2 is 4. I'm going to do the square root of 9. I know I'm squishing it, so it'll give you more space. The square root of 9 is 3, plus 2 is 5, so it's 1/5. Okay. So I'm going to do the same thing over here. I'm going to put in a 1. Square root of 1 is 1. I'm going to put in a 4. Square root of 4 is 2. I'm going to put in 9. Square root of 9 is 3. Here's the problem. We diverged. So we wanted this one to be smaller, and it wasn't. So either it's inconclusive, or I didn't pick a good enough comparison. Okay? So I'm going to try to compare again. Okay, so I'm going to try this one more time. Nate's loving this. We can compare to a different series. Okay, so maybe I didn't compare good enough. All right, so I'm going to choose a different series. It's either that or you have to find another test. Would you rather take the time and compare it to something else or do an integral test? I think we'd rather do this, right? So it takes practice, and I purposely did one where I'd have to compare it twice, right? Where I guessed wrong the first time so that you could see what happens, because this could happen to you, right? So instead of comparing to the square root of n, I'm going to compare to 1 over n, okay? Which we learned in the first session today. Hopefully you did your work. That's harmonic, right? So hopefully that helps us out. Okay, we know that is still a P-series. Okay, we know that the P is going to be equal to 1. And when it's exactly equal to 1, we know it diverges. You could also say that it's harmonic, and you know that it diverges. Did you guys watch Donald Duck? Did you watch the Donald Duck clip? Okay, that was important that you watch the Donald Duck clip. If you haven't done that yet, you need to do that. All right, so let's take a look at the comparisons here. So it's 2 plus the square root of n, and then 1 over n. We already know this one comes out to be 1/3, 1/4, 1/5, right? So I'm going to put the same values in. When I put a 1 in, I get 1. When I put a 4 in, I get 1/4. It's equal right now. When I put a 3 in, I get 1/9. Do you see how it just dipped below? Okay, if I did it again, it would still be bigger. Okay, so this one, sorry, it'd still be smaller. So this time, I got my smaller as my comparison. Okay, so now I can say that the original diverges because the smaller diverged. So since the original is greater than the smaller, okay, or the comparison, therefore the original n equals 1 to infinity of 1 over 2 plus the square root of n also, I'm going to write it under here, diverges. Okay. Okay, I know I took up some space for C. I'm going to still do C. I'm going to do it off to the right side there. I apparently needed, when I copied and pasted, should have left way more space for you guys. I'm sorry. Okay, so I'm going to give you, okay, So we are looking at this one here. I'm going to put it off here. I'm going to write in a different color so we can see it. So I am going to compare to something probably completely out there and a little bit different. Okay. I'm just going to try dropping the square root. Okay. I'm going to keep the 3, but I'm going to drop the square root. So I'm going to compare to the sum. And again, these will get, the more you do, the easier the comparison is going to be to see. Okay, so I'm trying to show you a whole bunch that are different so you start getting used to it. So I'm going to compare to this, which is really the same as saying that we have 3 over 2n, which is really the same as saying that, right? 1 over 3/2 times 1 over n. So I know we might not have seen a series like that, quite like that, but because I've got n to a power, which series do I have? Is it geometric or p series? I'm going to sit on my lap. Oh boy. All right, so that one's a p series. What's your p equal to? What's p equal to? What's my exponent on my n? Yeah, okay, so the exponent on your n is what your p is equal to. So it's equal to 1. So if my p is equal to 1, does it converge or diverge? What happened? You hit your head, come here, I'll kiss it. All right, so it diverges. Therefore, it diverges, which means I now need to compare, right? Okay. All better. Okay. I need to add kiss a child on the head to the bingo, apparently. Okay. So we are going to do our little comparison here. So I've got my original, which is n equals 1. Or sorry, I don't usually write that part. I usually just write the inside part. So 3 over n plus square root of n, and then I've got 3 over n plus n. I'm going to test some values. And again, Nate's thing might work, right? Deciding which denominator is bigger, okay? So I'm going to go ahead and plug in a 4. Well, I could put in a 1. I don't think 1's going to help us, though, because it's going to be 3/2 and 3/2. So I'm going to start with 4. So that would be 3 over, let's see, 4 plus 2, which is 6, compared to 3 over 8. Okay. So this is like 1/2. I'm going to put in let's put in a 9 just for good measure. Okay, so 3 over 8. 9 plus 3 is 12, so that would be 1/4. All right, and then we've got 3 over 18. Hi. I'm in the middle of teaching right now. Hello. Is it time for lunch for you? You're out early. Okay. Oh, Miss Marriott's mic didn't work. Okay, so go get them some sandwiches, please. All right, so the good news is that it's appearing that this second one is smaller, right? So we can put our word since in front. We have our BCSD, we have SD, the smaller diverged, okay? So therefore, okay, the sum as n equals 1 to infinity of the original, which was 3 over n plus square root of n, also diverges. You wanted me to do it again? All right, I'm going to give you guys a second to get that written. I don't think I have mine. This one was one of the ones that was on here. Hopefully. You got 4 bingos covered? See, it's not that hard to do, isn't it? No, we're playing Mrs. Ballard's teaching in the pandemic bingo. This morning, Andy broke a glass while I was teaching. I'm serious. So I've decided that if just, what else could go wrong? I need to put it on a bingo card. So, okay. Oh, no, this isn't one of the ones I had in there. I wonder where I stole this problem from. It's probably from this guy. Let's see. For my comparison. All right. Nate has 3 spots covered. All right. Okay. So let's take a look at this one here. Okay. Let's see what we can do with this one. All right. So I'm looking at D. Okay. One of them's 3, so Nate doesn't have very much covered. Okay. It's been pretty calm right now. We haven't done a long problem and gotten 0 at the end yet, right? These aren't the nature of them. And we don't have pi anywhere. There were some good pies, though. All right, so you see, now I just said pi, right? Okay, no pi in any of the problems today. I know, isn't it? Because we're not doing trig. If we were doing trig, then we'd have pi. All right, so this one here, I want you to think about if we were talking about going to infinity, right? And I were to reduce this. So remember, going to infinity, this piece here, these kind of become insignificant when we talk about infinity. So if I were to reduce that, wouldn't it be 1 over n squared? So I'm going to use that as my comparison. So compare to the sum as n equals 1 to infinity of 1 over n squared. So my goal is to try to create something that looks like a p-series or looks geometric. Okay. So if I look at this, what kind of series is that? What kind do I have there? Is it P or is it geometric? Because that's pretty much what Mrs. Ballard picks, right? P's and geometrics. Nate says P. Do we agree with Nate? JC says geometric. Okay, so so remember geometric has to have something like a number to a power, okay? A number to an n. This is geometric, okay? And then P series is n to a number. That's P, okay? So you got to make sure you get those 2 straight. So what's my P? So it is P series. What's my P equal to? My P is equal to 2. When we're equal to 2, does it converge or diverge? Does it converge or diverge on this one? Oh, we're greater than 1, so this one converges, right? So therefore converges. So I am hoping that this is my bigger one. I'm hoping it's BC. Okay, so I've got to do my little comparison now. So I'm going to write the word since. I've got n minus 1, not n plus 1, n minus 1 over n cubed plus 3, and I'm going to compare that to 1 over n squared. All right, it doesn't matter what values I pick. I'm going to pick a 1. Oh, if I pick a 1, I get 0 in the top, right? So this is 0 to begin with. And that would be 1. So far it's looking good, right? All right, I'm going to pick a 2. So I get 1 over 2 cubed is 8 plus 3 is 11. And I would do like 2 or 3 just to make sure. Okay. Sometimes though you'll see where it reverses order. This one's probably not going to do that. So this is 1/4. So I'm pretty confident that I know that this one's bigger. So therefore my original series, n equals 1 to infinity of n minus 1 over n cubed plus 3 also converges, not diverges, converges. Okay. It's a little bit, it's harder than P series. P series is the best, right? We want 1,000 P series on the test. Not going to happen, but that's what we want, all right? That once you kind of get the idea and you see how to create that comparison, it's not terrible. This is one of the ones you should know for the AP test, okay? It's one of those ones you got to have in your back pocket because when P series doesn't work, when geometric doesn't work, this is the one you want to go to, okay? All right. Last one here, okay? I want you guys to tell me in the chat. Let's see if you can figure this one out. Ignore all the numbers, okay? What do you think we should compare it to? If you ignore the numbers, what do you think you should compare it to? Reduce your algebra. What's your compare to? Scrape off the plus and minus 1. I like that. Divide 8 by 2. I'm not even worried about dividing 8 by 2. Ah, Madison. I like what Madison is saying. Nice job. All right. So look at what Madison did. We ignore these guys, right? Because going to infinity, who cares? Right? Going to infinity, who cares? Apparently, we lost Nate. Okay. And then, you know, ultimately, the coefficient when we go to infinity, it's going to matter a little bit, but not that much when we're cubing and squaring, because that's exponential, right? The cube is going to win over the squared, no matter what I multiply the squared by, okay? So if I go to compare to, let's compare to this sum as n equals 1 to infinity of 1 over n, which we know a lot about, right? That's easy, okay? What kind of series is that? Is it geometric? Is it a p-series? Is it integral? Is it nth term? All right, we're getting the hang of the p-series now. So p-series with p equal to 1, right? Because the exponent on the n is 1. If my p is equal to 1, does it converge or diverge? All right, nice job. It diverges. Okay, so since it diverges, I am hoping that that is the bigger series, right? Because for BC, SD, I'm sorry, I'm hoping it's the smaller series. All right, it's got to be the smaller one. So let's see what happens. So I'm going to write the word since. Hopefully I can use it. 8n squared plus 1 over 2n cubed minus 1. And we're checking out compared to n at 1 over n. All right, let's put some numbers in here. So let's see, I put in a 1. Let's see, 1 times 8 is 8 plus 1 is 9 over, let's see, 2 minus 1 is going to be 1. So it's 9. Whereas if I put a 1 in here, I get 1. It's looking pretty small right now. I'm going to go one more just to make sure, to be confident. So 4 times 8 is 32 plus 1 is 33 over 8. 16 minus 1 would be 15. So it's about 2, right? I put that in, I get 1/2. So I'm pretty confident that this is the smaller one, okay? Therefore, my original series n squared plus 1 over 2n cubed minus 1 also diverges, okay? And then this at the bottom is just a reminder blurb of what we've been saying the entire period.